Okay. Okay. Raise your hand. Oh, wait. Was I clicking? Okay. Raise your hand if you've ever questioned your existence in life. Yes, yes, some more people. Yes, yes, we love it. We love it. All right, great. I'm glad that we all feel the same. So today we're going to be presenting on the elements that make up your existence. Hi, my name is Me.
Tammy.
Will.
Christina.
And today we're going to be presenting on the elements of the body. So there are many elements within the human body, but today we're just going to be focusing on the four main ones. That includes oxygen, carbon, hydrogen, and nitrogen. And we're going to be starting off with oxygen. So Tammy, take the lead.
So I will be talking about oxygen. And we know oxygen is vital for life. And oxygen is a gas element that is essential for organisms to live. Oxygen is represented with the letter O in the periodic table, and it has an atomic number 8. Oxygen is found in the air we breathe, and the water we drink, and the food we eat. And oxygen, natural occurrence, is one of the most abundant elements on Earth. For example, it forms 20% of the atmosphere. It has 45% of the Earth crust, and it forms 89% of all the water mass on Earth. One of the things, fun facts for oxygen is that the oxygen is responsible for the bright lights of the aurora. So when you see the red lights and the yellow-green lights, it's because of the oxygen. Also, oxygen forms 65% of the human body. And what is the role of oxygen in the body? Well, in the body, there's a lot of chemical reactions happening all the time. So oxygen is one of the elements that is used in this reaction. For example, cellular respiration uses oxygen to make ATP. Oxygen is the last receptor in the transporter change when making ATP. So ATP is the primary energy source for important biological functions like muscle contraction or nerve impulse. So the chemical formula for the cellular respiratory, we can see it there. It's glucose plus oxygen produces carbon dioxide, water, and energy. The glucose, it comes from the food we eat, and the food we eat, and the oxygen comes from the air we breathe. And you guys can see it in the diagram. That's what we intake, and what we produce is energy. And as a result, the waste is we exhale carbon dioxide and we sweat and pee water. Why oxygen is so important? Because lack of oxygen can cause hypoxia, which is a low level of oxygen in the body tissue. And it can cause symptoms like confusion, difficulty breathing, and rapid heart rates, and this can lead to death. So now that we learned a little bit of oxygen, we're gonna go and learn a little bit more of carbon.
Great presentation, Tammy. All right. My name is Will. I'll be going over carbon. First, what is carbon? Carbon is a chemical element with a symbol C, and it is atomic number 6. This chemical element is non-metallic. The carbon element belongs to group 14 of the periodic table. You could find this in Ms. Sharma's packet or right there on the wall. All right. Natural occurrences. So what does carbon do? Carbon is a unique among the elements because it is its ability to form strong bonded chains sealed off by hydrogen atoms. Overall, the carbon atom is well suited to form basic skeleton or backbone of a micromolecule. Next is the role of carbon within our body. So what is the main component of carbon in our system? Carbon serves as the fundamental building block essential for the formation of sugar, carbohydrates, fats, protein, muscle tissue, and in our DNA. The primary source of our energy lies in the process of breaking carbon bonds within carbohydrates and protein. Fun fact, nearly 18% of our body is carbon. All right, as we all know, too much and too little of things can be good and bad for you. So when you have too much of carbon, you'll have headache, fatigue, difficulty breathing, respiratory failure, seizure, and coma. One of those causes is something called hypercapnia, which is when a person has too much carbon dioxide in their bloodstream. And when you have too little carbon, you start having symptoms like kidney disease and diabetic ketoacidosis. And that is caused by metabolic acidosis, which is when a poor control of diabetes can cause your blood to be more acidic, which can raise up your blood pH levels. And I'm gonna hand you guys off to Christina.
Okay, so today I'm going to be introducing the element hydrogen. So a little bit about hydrogen. Hydrogen is a chemical element. Its atomic symbol is H and atomic number is 1. So hydrogen is the lightest and most abundant element in the universe. So it makes up about 75% of its elemental mass. Hydrogen is non-metallic and readily forms single covalent bonds with most of the non-metallic elements. Some natural occurrences. Hydrogen is colorless, odorless, and tasteless, a tasteless gas at room temperature. In the Earth's atmosphere, hydrogen is relatively rare just in its molecular form, like H2, but it's a component of many other compounds, just like water, so H2O, and hydrocarbons found in fossil fuels as well. So hydrogen's role in the body, it makes up about 10% of the mass in the entire human body. It's present in all of our bodily fluids, which allows toxins and waste to be transported and eliminated from our bodies. With the help of hydrogen, the joints in our body remain lubricated and they're able to perform functions. So because of hydrogen, we're able to move and walk around. Some more roles in the body. The primary role of hydrogen in the body is more as of a component with H2O. So water containing hydrogen is vital for maintaining proper hydration levels. It's essential for various physiological functions, including our digestion, our circulation, and our temperature regulation as well. It is also involved in various metabolic reactions. So it participates in glycolysis, which is the breakdown of our glucose. And it is involved in the electron transport chain during cellular respiration. So that helps us generate our ATP. So some complications with hydrogen. Generally, it is non-toxic. It's a pretty safe element. It has a low reactivity, and usually it doesn't form any harmful compounds throughout our body. One concern is inhaling excessive amounts of just with any gas, including hydrogen. It's the displacement of oxygen in the air. So if the concentration of hydrogen becomes too high, it reduces the availability of oxygen in the air, which can lead to oxygen deprivation to our body and poses a risk of asphyxiation. So this would occur more like in a closed or poorly ventilated area. And with that, we will move on to nitrogen.
Thank you, Christina. All right, we're going to move on to the last element of today's presentation, which is nitrogen. So a little introduction about this element. Nitrogen is a tasteless, colorless, odorless gas that is found in group 15 of the periodic table. And it's used in many things, such as the air in your tires, in whipping cream dispensers, and desserts. This one up here is called the dragon's breath, in fertilizer, as well as in anesthesia. So now that we know a little bit about nitrogen, let's talk about where it comes from. So mainly nitrogen comes from the atmosphere, the air that we breathe. So just because it comes from the air, does that mean that we get our main source of nitrogen by simply breathing it in? Not quite. So nitrogen in its atmospheric form cannot be readily used. So we go through this fancy little thing called the nitrogen cycle. And here's a basic summary of it. The nitrogen cycle basically starts with getting atmospheric nitrogen, and then bacteria in soil takes this gaseous nitrogen from the air and converts it into a form that plants can use. So after the plants absorb it, they get their dose of nitrogen, and animals get their dose of nitrogen by eating the plants that contain nitrogen. After that, animals can go poop, and they poop back onto the soil where the bacteria is, and that bacteria takes the leftover poop from, the leftover nitrogen from the poop, and they convert it back to atmospheric nitrogen. So the cycle begins all over again, and it's like the recycling of nitrogen. So that's how many organisms get their nitrogen, and also how we as human beings get nitrogen from eating other organisms that have nitrogen. So now that we know how we get nitrogen, let's talk about the role that nitrogen plays within the human body. So first off, nitrogen is important for the structure of amino acids, and amino acids help to form fancy things called proteins. And these bad boys are like responsible for a lot of things in the human body, such as your hormones, antibodies, enzymes, and tissues, like the Lego bits that build up all your muscles, bones, and whatnot, all that fancy jazz. Second, nitrogen also plays an important role in nitrogenous bases. And a little recap, nitrogenous bases are part of your DNA and RNA. And DNA and RNA are kind of like the cookbook of your body, right? And it makes you. But as awesome as nitrogen sounds, too much or too little of anything is never good. So deficiency in nitrogen can happen due to a poor diet, specifically lack of protein, and it can result in something called a protein energy malnutrition, short for PEM. This is mainly common in impoverished areas where there is not a lot of food or nutritious food that is readily available. But too much of nitrogen can also cause problems, because if you use too much of it, well, it's pretty uncommon, but if you use too much of it, it can cause severe burns as well as other complications. And you usually get it from job exposure or misuse. So let's say you work with a lot of liquid nitrogen or gaseous nitrogen. That's a way that you can overdose on nitrogen. And if you misuse it, let's say you want to F around with some nitrogen or liquid nitrogen, obviously you're going to get hurt and you're going to get injured by doing that. So that is the last element, and I'm going to hand it over to Christina to focus on our recap.
Okay, so just to do a little bit of review, we talked about the four main elements that are in our body. So the most abundant is oxygen, which makes 65%. We have carbon, makes 18%. Nitrogen, which makes 3%, and hydrogen, which makes 10%. There are others, but those are just the main four present in our body. So with that, I hope that you guys were all able to learn a little something about how elements play a role in our bodies. And thank you for listening to our presentation.
I got it.
Stop recording.
Oh, no.
Oh, no. Stop. Oh, yeah. Yes.